Hi, I'm Miss Hall, and this is Lesson 17, Solving Quadratic Equations, Real-Life Problems. We're going to focus on a very specific real-life problem, and that is when something is dropped from a height. When an object is dropped, its height h in feet above the ground after t seconds can be modeled by the function h equals negative 16t squared plus h sub 0, where h sub 0 is the initial height in feet of the object. The graph of h equals negative 16t squared plus 200, representing the height of an object dropped after initial height of 20 feet, is shown on the left. The model h equals negative 16t squared plus h sub 0 assumes that the force of air resistance on the object is negligible. Also, this model applies only to objects dropped on Earth. For planets with stronger or weaker gravitational forces, different models are used. Okay, so for this lesson, you're expected to plug information into this formula. On the regions, I would not expect them to have you know this formula, but for lesson 17, we're going to be using this formula a lot. We're going to be given initial heights that something is dropped from, and we're going to be plugging that into that h sub 0 value. Example 6, modeling a dropped object. For a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. Write a function that gives the height h in feet of the container after t seconds. How long does the container take to hit the ground? A, writing a function. So h of t is going to equal, it's the formula from before, negative 16t squared plus the initial height, which is 50 feet. Right, this 50 is h sub 0. I'm also expected to answer how long does the container take to hit the ground. So I want to know when is the height 0 of this container. So 0 equals negative 16t squared plus 50. Subtract 50 from both sides. And I'm solving for the time. Get negative 50 over negative 16 equals t squared. T squared equals 25 over 8. Right, I reduce that fraction, and then I take the square root of both sides, and I get that t is equal to plus or minus the square root of 25 divided by 8. At this point, I can plug this into my calculator, and I'll get that t is equal to plus or minus 1.8 seconds, or approximately. I'm rounding there, so I'll put approximately. The idea of the container hitting at negative 1.8 seconds doesn't make sense, so we cancel out that negative answer, and the answer is the container hits the ground 1.8 seconds after it is dropped. And question B, find and interpret h of 1 minus h of 1.5. So for B, I'm taking h of 1 minus h of 1.5. So to find h of 1, I'm going to plug 1 into my function. So we have negative 16, 1 squared plus 50. And h of 1, I just put that in my calculator. I don't even simplify it by hand. And I get 34. And then h of 1.5, I put 1.5 in my calculator. 1.5 squared plus 50. H of 1.5 equals 14. So I take 34 minus 14, and I get 20. And I'm supposed to interpret that. So I'm thinking I want to visualize this picture of this container being dropped at 0,50 feet. It hits the ground at 1.8,0 seconds. And so between, let's call this 1,34 and 1.5,14, I am finding the drop from h of 1 to h of 14. So how much the egg dropped by in that time as the time continued. So the container fell. Let me abbreviate. The container fell 20 feet between 1 to 1.5 seconds. If the container is dropped from a height of 80 feet, our function will be h of t equals negative 16t squared plus 80. How long does it take to hit the ground? So we'll plug in a height of 0 and solve for t. T equals plus or minus the square root of 80 over 16, which is approximately 2.2 seconds. Now find and interpret h of 1 minus h of 1.5. H of 1 is at time 1. Put this in my calculator to get an h of 1 of 64. H of 1.5 equals 44. 64 minus 44 is 20 feet. So to interpret that, this container fell 20 feet between 1 and 1.5 seconds, which feels like deja vu because that's the exact same answer from the example 6.